Hello everyone, good evening and welcome to my channel Aptitude Club. Hope all of you are doing well. So this is the first session for CAT 2023. A lot of you would be starting your preparation right now, and I thought of starting with a very new and unique topic that is reminders. Now, don't worry that all of a sudden why start with this topic, and has it anything to do with the previous knowledge of other topics? Absolutely no. It is something very new, and all of you can understand even if you are reading it from the beginning, or you are someone who is just starting your CAT preparation and you are watching this video for the first time. Do not worry, you will absolutely understand this. Just before we start the topic, I'll say a little bit about the relevance of the topic. Now, remainders belong to the number system portion of quantitative aptitude. And if you look at the number of questions, we don't get too many questions on this area, maybe one or two maximum. Okay, on the maximum side. But you will think that okay, if one question, why worry so much about this? If we understand remainders in proper way, we can solve any question as far as the exam pattern is concerned in less than 30 seconds. That is the advantage of this part, because this is easy. But the disadvantage also, I'll say, that to solve or to be able to get to that stage where you can solve any question on remainders, you need to know maybe a lot of theorems. Okay, so that is why it is necessary if you start it early, so you'll get some time to adapt. Okay, so it's not difficult, but definitely something which will be new to you, or a new perspective of how do we look at remainders. Now, remainders is something we have always heard of, quotient, remainder, divisor, dividend, and division, and everything we have always heard of. But how do we look at this concept of remainders from CAT perspective or from these exams perspective? That is what I am going to share in this series of sessions, remainders ka. And in this series, I'll cover everything A to Z of remainders. And if you watch these sessions, total end-to-end series, I can assure you that there won't be any question of remainders you will not be able to solve. Okay, we'll definitely go deeper into the concepts, and absolutely feel free, okay, to learn. Do not stress yourself too much that how relevant is it, and how many questions can come from this. After we have learned, then only we can prioritize. Okay, this chapter we get more questions from, this chapter we get less questions from, how much we should prioritize and all these things can happen after we have learned something. Before we learn, if we worry too much and get selective, that's a dangerous road to walk on. So my advice for all 23 aspirants: enjoy the session, and definitely you will find a lot of insights in these theorems. And in the course of the session, if you do like my way of teaching, and you find this channel useful, I'll sincerely request all of you to subscribe to the Aptitude Club channel. It's a new channel, but I'll be sharing my insights and how I look at the quants portion, and I'll try and explain the concepts and the way I look at them in these videos on the channel. So if you're new to the channel or you'll be watching this, do subscribe and like the video and support me. So without further delay, let us begin. So remainders, part 1. This is the first video, and we'll start with basic remainder theorem. This is like the parent theorem, and every other theorem is derived from this. Okay, if you understand this, then you will understand remainders in its entirety, and how things work out on remainders you will be able to understand. Okay, so what is this theorem basically? Basic remainder theorem. So first clause, or the first statement of the theorem, is remainder of a sum is equal to the sum of remainders. Remainders of a sum is equal to the sum of remainders. What do you mean by this? For an example, I'll say remainder of a plus b divided by c. This is remainder of a divided by c plus remainder of b divided by c. What do you mean by this? Again, let us take an example. Suppose I'll say the remainder of 59 divided by 7. Now 59 divided by 7, all of us know that the remainder will be 3. क्योंकि 7 8 is 56, तो remainder रह गया 3. You divide it in this way: 59 divided by 7. 7 8 is 56. This is what we call as the remainder. Now if I break 59 as sum of any two numbers, not just two, तुम 3 numbers, 4 numbers, n numbers, तुम जैसे भी you want you can break it as a sum. Just for explanation sake I am breaking it as sum of two numbers. So it is 50 plus 9 divided by 7. I am taking it in random, you can break it in any way you want. Okay, so this is like remainder of 50 by 7 plus remainder of 9 by 7. 9 by 7 matlab 9 divided by 7. Now 50 divided by 7 remainder is 1. 7 sevens are 49 and remainder 1. And 9 divided by 7 remainder is 2. So 1 plus 2 I get remainder 3. Now someone else will say, no, what if I break it in this way? 50 I'll break it as 45 and plus 10 plus 4 divided by 7. So you can write it in this way, it is remainder of 45 divided by 7 plus remainder of 10 divided by 7 plus remainder of 4 divided by 7. You can write it in this way. Now 45 divided by 7 remainder is 3, 10 divided by 7 remainder is again 3, 4 divided by 7 remainder is 4. But when you add this, 3 plus 3, 6 plus 4, I get 10. Now 10 cannot be the remainder. Always while division, this is very common and you would understand this, that remainder has to be always less than the divisor. Is it correct to conclude this? Remainder has to be always less than the divisor. Divisor से तो बड़ा नहीं हो सकता remainder. So remainder is always less than the divisor. So अगर remainder यहाँ पे process में 10 आ गया, you divide it again by 7 and then I'll again get the remainder as 3. So you break it in any way you want, but remainder of a sum is equal to sum of remainders all the time. You want to break it in any way, you break and then find the remainders, ultimately you will reach the same answer. Now this might look very simple and obvious at this first look, पहले थोड़ा obvious लग सकता है, but how is it used? Once we go into the questions you will get to know what is the importance of this. So this is the first part. Okay, there is a second part and then we'll come to the question so that you can directly relate. Very simple, very easy, and if you understand this, it lays the foundation for the upcoming theorems, which I'll be taking in the upcoming parts. So if I come to the second clause, I can write remainder of a product. Remainder of a product is equal to the product of remainders. Remainder of a sum is equal to the sum of remainders, and remainder of a product is equal to the product of remainders. Again, I can write it as remainder of A into B divided by C is remainder of A divided by C into remainder of B divided by C. So again, for an example, if we take remainder of, let us say, 56 divided by 9. So remainder of 56 divided by 9, 9 6 is 54. So remainder is 2. Now 56, if I break it in this way, 56 is like 9 into 6, sorry, 9 into 6, so 54. Right? Suppose I'll write it in this way, 56 is like 28 into 2. We can write it in that way, 28 into 2 divided by 9. So this becomes remainder of 28 divided by 9 into remainder of 2 divided by 9. So 28 divided by 9 remainder is 1 and 2 divided by 9 remainder 2. If you would be wondering 2 divided by 9 how is the remainder 2? So you cannot divide. So 9 zeros are 0 and 2 is the remainder because already वो number से less है. तो फिर हम कैसे divide करेंगे? तो आएगा 2 remainder. So overall the remainder is 2. You can break 56 in any other way you want. वही answer आएगा. Ultimately you will get the same answer. Suppose you break into 56 in this way. 4 into 14 divided by 9. So this is remainder of 4 divided by 9 into remainder of 14 divided by 9. 4 divided by 9, so remainder is 4. But 14 divided by 9 remainder is 5. So I get 20 now. But 20, again it exceeds 9. Remainder has to be less than the divisor. So 20 divided by 9, you will again get the remainder as 2. So these two clauses, remainder of a product is equal to product of remainders and remainder of a sum is equal to sum of remainders. This explains two very basic properties of remainders, that remainders are additive and remainders are multiplicative. Okay, and we will use this nature of remainders across the questions. Okay, very widely used and very useful. Okay. So for an example, एक example लेते हैं question का, you will understand. Suppose there is a question like this. Now find the remainder. Find the remainder when 120 into 122 plus 119 into 123 is divided by 11. Suppose this is given. So we are supposed to calculate this remainder of 120 into 122 plus 119 into 123 divided by 11. Now obviously we are not going to multiply, then add and then find the remainder. That is one way to do it, but it will be too lengthy and then there's no point of asking such questions. So अगर ऐसा question आता है तो how do you deal with it? The moment you see this number 11 and you look at the numbers given 120, 122, 119, 123, all these numbers are close to the square of 11. 11 square is 121. And can I say this, that 121 is divisible by 11? जब 121 को 11 से divide करोगे तो remainder will be how much? 0, because it is divisible. That is why the remainder is 0. Now if remainder of 121 divided by 11 is 0, what will be the remainder in case of 122? It will be plus 1, because abhi it is 1 more. In case of 123 the remainder is plus 2. I can say in case of 120 the remainder is minus 1, because it is 1 less, and in case of 119 it is minus 2. Now for a lot of you this would be new, that remainders फिर minus में कैसे लिख रहे हैं? What's the point of writing minus 1, minus 2? Now to elaborate it, I'll take a very separate session on negative remainders. That is also a concept. But to understand this, let me put it in this way. Try and think of it in this way. Negative remainders, let me write here. So suppose 121 divided by 11. How do you divide this? 11 into 11 is 121, remainder is 0. So when I take 122, I can write it in this way. 11 into 11 is 121 and I am left with 1. This is the remainder. Similarly, when I write 119 divided by 11, you will say, sir, ideally we should do it in this way. And 9 should have been the remainder, but 9 is your positive remainder. Now what if I do this? Is this wrong? I'll write 11 into 11 is 121 and I'll just subtract this. Mathematically this is also correct, isn't it? There is nothing wrong. Now this is not conventional and we don't divide it in this way, but this is not mathematically wrong. So this 2 is also the remainder and we call it as the negative remainder. So it means this 119, it is 9 more than a multiple of 11, and I can also write it in this way, that 119, it is 2 less than the next multiple of 11. Okay, this is how we define negative remainders. I hope this is making sense. Very simple. This might be a new thing for a lot of you, because we don't write remainders in negative way, and ऐसा कभी कोई division करता नहीं है. Although this is mathematically correct but unconventional, we don't write it in this way. So why do this? Negative remainders as a concept, they are used to solve questions only. We never write the answer in form of a negative remainder. Just for convenience of calculation, we'll use this. तुम चाहो तो positive remainder भी use कर सकते हो. No wrong in it. You can use negative remainders or positive. We can do it in both ways. यहाँ पे मैंने negative लिख लिया, but तुम चाहो तो इसको positive remainder में भी लिख सकते हो. Okay, if you want to write it in the positive remainder case, let me write it in this. 120 divided by 11, remainder is plus 10, and here it is plus 9. Now because remainders are additive, now यहाँ पे ये plus है, but these two are multiplied, so I can break it as remainder of 120 into 122 divided by 11, plus remainder of 119 into 123 divided by 11. Now 120, you will further break it in this way. It is remainder of 120 divided by 11 plus remainder of 122 divided by 11. Sorry, यहाँ पे plus लिख लिया. This is a product. Okay. But यहाँ पे plus है, and again this is a product. So remainder of 119 divided by 11 into remainder of 123 divided by 11. And we know the individual products now. मतलब individual remainders पता है हमें यहाँ पे. So I can write it in this way: 120 divided by 11, remainder is 10, here remainder is 1, and here remainder is 9, and here remainder is 2. So 10 into 1, it is 10, plus 9 into 2, it is 18, and 10 into 18, it is 28, which exceeds 11. So 28 को फिर से 11 में divide करो, I'll get remainder as 6. Okay, we do this. 28 को फिर से divide करेंगे, remainder finally 6 आएगा. Now it solves like makes our calculation very easy. It could have been much easier if I'll use negative remainders. I'll show you how. मैंने अभी सीधा सीधा positive remainders जो हमें usually समझ आता है, मैंने वही use किया है यहाँ पे. And I hope all of you are able to make sense of this. Okay, very simple. Individually remainders nikala, and I use those two properties, that wherever there is a product, I'll do a product. Wherever there is a sum, I'll do a sum. But if I would have used the negative remainders logic, I can write it in this way. Let me put it here. That remainder of 119 into 122, 123, and 120 into 122, this divided by 11. So you see the remainder here is minus 2, here it is plus 2, and here the remainder is minus 1 and it is plus 1. तो तुम बस यही मल्टीप्लाई करो जो यहाँ पे minus 2 into plus 2 plus minus 1 into 1. So I get minus 4 plus minus 1. So basically I get minus 5. Minus 5 is the negative remainder. Now note this, that to make a negative remainder positive, keep adding the divisor. अगर negative remainder में आंसर आया, you keep adding the divisor until it has become positive. Until it has become positive. Very simple principle. Until it has become positive. So minus 5 आया, that means my actual answer is, to the negative remainder I'll add the divisor, which is 11. So minus 5 plus 11, I'll get 6. अब तुम्हारे माइंड में क्वेश्चन आ रहा होगा, क्यों डिवाइजर क्यों ऐड करें? Look at this. Here the divisor was 11, and this is the positive remainder, and this is the negative remainder. So if I say the negative remainder is minus 2, what should I add to this to get 9? This should be your divisor. तो नेगेटिव रिमाइंडर में डिवाइजर ऐड करोगे तो तुम्हें पॉजिटिव रिमाइंडर मिल जाएगा. वेरी सिंपल प्रिंसिपल, एंड वो यूज करते हैं. तो you see how easily I can solve this. I could solve it in this way also. This is nothing wrong, but you can solve it in this way also. Now that is why I said this is a very new thing. Like we may not have thought of remainders in this kind of a system, because whenever we divided, always the division has two results: quotient and remainder. We always focused on the quotient part. We never really looked at the remainders. हम बोल देते थे not divisible, but ये remainders को लेके ये principle सब अभी बन रहा है. This is what basic remainder theorem is all about. You can take examples on your own, and in the upcoming sessions also I'll elaborate more and more on this negative remainders, how it is used, what all are the applications and all. धीरे धीरे होगा. अभी नया हो तो थोड़ा तुम्हें लग सकता है this is something very new, but आराम से काम head में try and understand, take numbers yourself, experiment and देखो ये principle is it working with your example or not. If not, feel free to write in the comment section. I'll try and explain. If not, I'll again take another video to take more examples and explain you on this. Okay. But I hope this is clear. Two very basic principles: remainder of a sum is sum of remainders, and remainder of a product is product of remainders. And we took an example on this. Let us see a few questions. Let me take another example before going to the questions. और एक example लेते हैं. Based on negative remainder. Suppose I'll say remainder of 24 divided by 7. 24 divided by 7. So you divide 24 in this way. 7 3s are 21 and the remainder is 3. And this is the quotient. What is the definition of quotient? Like we divide but we never really think about all these things. What do you mean by quotient? Quotient is the number of times the divisor can be subtracted from the dividend. The meaning of quotient is this: the number of times you can subtract the divisor from the dividend. This is your divisor and this is your dividend. So मैं 7 को 24 से कितना टाइम सब्ट्रैक्ट कर सकता हूँ? I can subtract it 3 times. So that is why the result is 3, and you are left with 3. So 3 is your positive remainder. But I can also do this, that 7 4s are 28 and the remainder is minus 4. This is also my remainder, but this is now the negative remainder. Like what if I subtract again? So subtraction का end कहाँ पे होता है? Now I can subtract it again also. You will say why not this sir? अगर यही कर ही रहे हैं so why not this and write it as minus 11? ये भी तो correct है, ये भी correct है, and that is the reason precisely why we don't write the remainders in negative, because ऐसे तो बहुत सारे हो सकते हैं. There will be no end to the division. So remainders in negative form है, we just use it for convenience of calculation, but always conventionally it is written in positive way. So remainder when 24 is divided by 7 is either plus 3 or minus 4. ये positive है and ये negative है. And you again check the principle that if I have the negative remainder, in negative remainder minus 4 में you add the divisor, that is 7, and you get the positive remainder. So this principle always works, always. Alright, so hope this makes sense, and these two examples made it a little more clear to you. Let us go to the questions. 2-3 questions करेंगे so that you will understand. Let's take a look at this. There are two numbers a and b such that when they are divided by 6, they leave remainders 4 and 5 respectively. That means remainder of a divided by 6 is equal to 4 and remainder of b divided by 6 is equal to 5. So I'll have to find remainder of a square plus 2b plus ab divided by 6. So just ये break करेंगे. This is remainder of a square divided by 6 plus remainder of 2 into b divided by 6 plus remainder of a into b divided by 6. This a square I can write it as a into a and बाकी सब वैसे ही रहेगा. You can skip the steps. मैं just for clarity I am writing these steps, but तुम directly once you get comfortable you can directly write these things. Now look at this. A divided by 6, we know the remainder is 4. So in both the cases it is 4, and because it is a product, remainder of a product is product of remainders, so 4 and 4 multiply हो जाएगा. 2 divided by 6, the remainder is 2. B divided by 6, the remainder is 5. A divided by 6, the remainder is 4. B divided by 6, the remainder is 5. Now product and sum जैसे जैसे है बस वैसे वैसे करेंगे. 4 into 4 16 plus 2 into 5 10 plus 4 into 5 20. So I get 46 divided by 6, because 46 तो बहुत बड़ा नंबर हो गया, again divide हो सकता है, and the final remainder is 4. 6 7 are 42 and the final remainder is 4. So very 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 simple principle, but तुम आगे जाके देखोगे how powerful this is. Even if you don't know like 10 theorems on remainders, but if you do know this, you will find the questions very easy to comprehend. Okay. Then steps of calculation lengthy कितना हो रहा है not, that will depend on practice and how much shortcuts you know and कितना सोच पा रहे हो question पे, उसके ऊपर depend करेगा, but we have to start somewhere and this is the start. All right, hope this is clear to all of you. Let us come to this one. This was a CAT 1998 question. A certain number when divided by 899 leaves a remainder of 63. So I'll take let this number, certain number, let it be n. So remainder of n when divided by 899 is equal to 63. So can I write n as 899 into k plus 63? How did I arrive at this principle? We'll use the simple logic that dividend is divisor into the quotient plus remainder. ये principle तो सबको पता होगा. So n is your dividend, it is divisor. K, let us say, is any quotient. We don't know what the quotient is, doesn't matter also. But it is 63 more than a multiple of 899. तो जब 899 से divide किए मतलब continuous subtract कर रहे हो, 899 subtract करते जा रहे हो, last you are left with 63 and you couldn't subtract any longer. So remainder is 63. So this is the value of n. So once we know what n is, question is saying find the remainder when the same number is divided by 29. So I'll have to find the remainder when n is divided by 29. n को 29 से डिवाइड करने का मतलब है 899 into k plus 63 को 29 से डिवाइड करो. So it is like remainder of 899 divided by 29 into remainder of k divided by 29 plus remainder of 63 divided by 29. Now 899 divided by 29, what will be the remainder? Now 0, because 29 into 31, if you multiply this you will get 899. So basically 899 is a multiple of 29, वो divisible है. Now wherever it is divisible, remainder is 0. What is the remainder when k is divided by 29? We don't know, because we don't know the value of k. But whatever value this is, 0 into that तो overall 0 आ ही जाएगा. And 63 divided by 29, remainder is 5. 29 2 is 58, उससे 5 ज़्यादा है. So I get 0 plus 5. My overall answer is 5. And this was an actual CAT question, and look how simple this is, how simple this question is. And if you know the principle, you will only take 30-40 seconds to solve these questions, and nothing difficult about it. Okay, hope this makes sense. People who have been watching so far, I hope you are enjoying the session and you are able to understand this. If I am doing justice to the concept and you are able to really understand, do subscribe to the Aptitude Club channel. Let's take a look at this one. Sum of the digits of a number x is 13. So there is a number x. X का sum of the digits is equal to 13. X क्या है पता नहीं है. Sum of the digits is 13. Now look at a very interesting principle. I'll write a statement and then try and think whether it is correct or not. यहाँ पे 3 is the divisor, and specifically that is why they have written sum of digits. So I'll write remainder of a number when divided by 3 is same as the remainder of a number when divided by 3 is same as the remainder when its sum of digits is divided by 3. I can write this. Remainder of a number when divided by 3 is same as its sum of digits divided by 3. You can take it as principle and check. कोई भी number check करो. For an example, I'll take remainder of 19 divided by 3. The remainder is 1, and तुम sum of digits 1 plus 9 ले रहो 10, and when 10 is divided by 3 the remainder is again 1. कोई भी number को 3 से divide करने में जो remainder आएगा उसका sum of digits को भी 3 में divide करने से same remainder आएगा. So sum of the digits of the number x is 13. So from this principle I can conclude remainder of x when divided by 3 is same as remainder of the sum of digits of x when divided by 3. So 13 divided by 3, remainder 1. So I can say x को जब 3 में divide करेंगे remainder is 1. So what is the remainder when x to the power 4 is divided by 3? X to the power 4 I can write it as x into x into x into x divided by 4 divided by 3, and every time you will get a remainder 1, 1 into 1 into 1 into 1, and overall my remainder is 1. That is the answer. Very simple question. X into x into x into x, every time you are getting remainder 1. So same principle, remainder of a sum is the sum of remainders, remainder of a product is the product of remainders. These two principles are going to be used every time, every question. Okay, so this is the beginning and the foundation of basic remainder theorem. I hope all of you got a preliminary idea. This is not the end of it. We'll elaborate more on the upcoming sessions. So we'll take it slow, but I'll like try and give you the best possible examples in the simplest possible ways, so that you don't get afraid of this like area remainders. And by the end of this remainder series, you will find it absolutely comfortable to solve any questions on remainders. Okay. So that was it from my end for this session. So I hope all of you like enjoyed the concepts and got some insights, and I could really help in your understanding of the concept of reminders. If you enjoyed the video, please do subscribe to my Aptitude Club channel and like the session, share it with your friends, and help the channel grow. We'll meet again in yet another session of this reminders part 2. So stay updated, and have a nice day all of you. Thank you. Bye bye.